Hello, good day everyone. I am Kimberly A. Salinas and I am going to discuss the graph of functions. So before we proceed to our discussion, let us know first what is our learning outcome. So the learning outcome for this topic is to sketch the graph of a functions. So for review, what are the different types of functions? The linear function, quadratic function, cubic function, rational function, even and odd function, absolute value function, piecewise function, and greatest integer function. The first type of function is the linear function. It is the simplest type of function where the graph is line. So to graph a linear function, we need only 2 points in keeping with Euclid's axiom. First is the 2 points determine a line, or the shortest distance between 2 points is a line. So to understand it better, we have an example. So we have to determine the domain and range and sketch the graph of y is equals to 2x plus 3. In this case, there are no restrictions on x. Therefore, the domain of the function is all real numbers. In this linear equation, the slope is 2, which is the coefficient of x. This means that for every increase of 1 in x, y increases by 2. Since there are no limitations on the slope, the range of the function is also all real numbers. So in sketching the graph, we need to get first the value of x. So 2x plus 3 is equals to 0, 2x is equals to negative 3, and we have to divide it by 2. So our x is equals to negative 3 halves or 1.5. So this is now our graph. The next type of a function is the quadratic function. A quadratic function is a function of the form f of x is equals to ax squared plus bx plus c, where a is not equal to 0, and where a, b, and c are real numbers. The domain of quadratic function is set of all real numbers. So note that in a quadratic function, there is a power of 2 on your independent variable, and that is the highest power. So the graph of a quadratic function is a curve called a parabola. Parabolas may open upward or downward and vary in width or steepness, but they all have the same basic U shape. So when you have a quadratic function in either form, if a is greater than 0, then the parabola opens upward. If a is less than 0, then the parabola opens downward. So to understand the graph of a quadratic function, let's have an example. So we have to sketch the graph of f of x is equal to 2x squared plus 8x plus 7. So begin by writing the quadratic function in standard form. The first step in completing the square is to factor out any coefficient of that is not 1. So f of x is equals to 2x squared plus 8x plus 7. So you have to factor 2 out of x terms. So we have 2 times the quantity of x squared plus 4x plus 7. Then add and subtract 4 within parentheses to complete the square. 2 times the quantity of x squared plus 4x plus 4 minus 4 plus 7. So after adding and subtracting 4 within the parentheses, you must now regroup the terms to form a perfect square trinomial. They can be removed from inside the parentheses, but because of the 2 outside the parentheses, you must multiply negative 4 by 2. So we now have 2 times the quantity of x squared plus 4x plus 4 minus 2 times 4 plus 7. Then simplify the equation. So we now have 2 times the quantity of x squared plus 4x plus 4 minus 8 plus 7. So we now have the standard form 2 times the quantity of x plus 2 squared minus 1. So from this form, you can see that the graph f is a parabola that opens upward with vertex negative 2 and negative 1. So the domain of this graph is x such that x is an element of real numbers, and the range is y such that y is greater than or equal to -1. So para mahibalaan nato ang graph ani nga function, let's have the table of values. So for our x, the -1, -2, and 0. So gamito nato tong standard form, imuhang i-substitute ang value ni x. So we now have the f of x, the 1, -1, and 7. So mauna ni siya ang ma-form na graph out of this given function. The third type of a function is the cubic function. Any equation in the form of f of x is equals to ax cubed plus bx squared plus cx plus a, where a is not equal to 0, is called a cubic function in x. So notice that the graph of the cubic function can be traced accurately using the derivative test, but we will illustrate this function when both b and c are zeros. So to understand the graph of the cubic function, let's have an example. Determine the domain and range and sketch the graph of y is equals to x cubed. So for y is equals to x cubed, the domain is x such that x is an element of real numbers. The range is y such that y is an element of real numbers. So the intercepts are 0 and 0. So this is now the graph for y is equals to x cubed. The fourth type of a function is the rational function. If a function can be expressed as the quotient of two polynomial functions, it is called a rational function. Any equation defined by f of x is equals to p of x over q of x, where q of x is not equal to 0, and where p of x and q of x are algebraic functions, it is called a rational function. So to understand the graph of the rational function, let's have an example. So we have to determine the domain and range and sketch the graph of y is equals to 1 over x squared. So the domain of y is equals to 1 over x squared is x such that x is an element of real numbers, where x is not equal to 0, and the range is y such that y is greater than 0, and where y is not a real number. So this is the graph of y is equals to 1 over x squared. The fifth type of a function is the even and odd function. But first, let's have the even function. For a real valued function f of x, when the output value f of negative x is the same as f of x, for all values of x in the domain of f, the function is said to be an even function. So the form of an even function is f of negative x is equals to f of x for all values of x. So let's have an example to understand the graph of the even function. So we have to determine the domain and range and sketch the graph of f of x is equals to x squared plus x raised to 4. So first, we have to replace x with a negative x. So f of negative x is equals to negative x squared plus negative x raised to 4. So f of negative x is equals to x squared plus x raised to 4. So f of negative x is equals to f of x. So therefore, it is an even function. So the domain of this function is x such that x is a real number, and the range is 0 and infinity. So this is now the graph of the even function. Next is the odd function. For a real valued f of x, when the output value of f of negative x is the same as the negative of f of x, for all values of x in the domain of f, the function is said to be an odd function. So the form of an odd function is f of negative x is equals to negative f of x for all values of x. So to understand the graph of an odd function, let's have an example. we have to determine the domain and range and sketch the graph of f of x is equals to x cubed plus 2x raised to 5. So first, you have to replace x with a negative x. So we now have f of negative x is equals to negative x cubed plus 2 times negative x raised to 5. So we now have f of negative x is equals to negative x cubed plus negative 2x raised to 5. Then, factor by negative 1. So we now have f of negative x is equals to negative 1 times x cubed plus 2x raised to 5. So, therefore, it is an odd function because it forms f of negative x is equals to negative f of x. So the domain is x such that x is a real number. And the range is y such that y is a real number. So now, this is the form of the graph. Next type of function is the absolute value function. An absolute value function is a function where the variable is inside the absolute value bars. The absolute value of a number is always positive, and it can never be negative. The form of the absolute value function is y is equals to the absolute value of x, where x is a real number. So, to understand the graph of the absolute value function, let's have an example. We have to determine the domain and range and sketch the graph of y is equals to the absolute value of x plus 3. So for any real number x, the expression x plus 3 can take any value. So our domain is x such that x is an element of real numbers. So considering y is equals to the absolute value of x plus 3, the absolute value function yields non-negative values. Hence, y is always greater than or equal to 0. So our range is y such that y is greater than or equal to 0 and y is an element of real numbers. So to sketch the graph of y is equals to the absolute value of x plus 3, start with the parent function y is equals to the absolute value of x and shift horizontally by 3 units to the left. So the vertex of the V-shaped graph will be at negative 3 and 0 because x plus 3 is equals to 0, x is equals to negative 3. So this is now the form of our graph. The seventh type of function is the piecewise function. A piecewise function is a function f of x which has different definitions in different intervals of x. The graph of a piecewise function has different pieces corresponding to each of its definitions. So, let's have an example to understand the graph of piecewise function. Let f be the function defined by f of x is equals to x minus 1 if x is less than 0, 5 if x is equals to 3, 2x plus 1 if 3 is less than x. So we have to determine the domain and range and sketch the graph. So the domain of f of x is negative infinity to positive infinity. The graph consists of the portion of the line y is equals to x minus 1 for which x less than 3, the point 3 and 5, and the portion of the line y is equals to 2x plus 1 for which 3 is less than x. The function values are either number less than 2, the number 5, or numbers greater than 7. So therefore, the range of f is the numbers 5 and those numbers in negative infinity to 2 union 7 to positive infinity. So this will be the form of our graph. The last type of function is the greatest integer function. The symbol x is defined as the greatest integer, which is less than or equal to the number x. The greatest integer function is defined by f of x is equals to x, the largest integer n, such that it is greater than or equal to x. The domain is the set of real numbers, while the range is the set of integers. Thus, the domain is x such that x is an element of real numbers and the range is y such that y is an element of integers. So to understand the graph of the greatest integer function, let's have an example. So now we have to determine the domain and range and sketch the graph of f of x is equals to the greatest integer less than or equal to 0.5. So, f of x is equals to the greatest integer less than or equal to 0.5. It is equal to f of x is equals to 0. So, for the domain, x such that x is an element of real numbers, and the range is y such that y is the greatest integer less than or equal to 0.5. So now, this is the form of our graph. That would be all. I hope you learned something. Thank you for listening.